Hi everyone, welcome to our reality capture education series. In today's session, you will learn how to create impressive surface models in a snap. I'm Christine Grail with Leica Geosystems, part of Hexagon, and I will be your moderator for today's session. Our instructor today is Seth Gulich. Seth is one of those people that if you are spending any time at all in reality capture circles, you will probably hear his name come up. I often hear about just how knowledgeable he is and how helpful he is. And so I am honored to be able to have him as our instructor here today. For those of you who don't know Seth, he is a professional surveyor and mapper who has nearly 10 years of experience in surveying and office field work, business development, training, project management, and workflow optimization. He was named one of XYHT's 23 young geospatial professionals to watch. He's an FAA certified drone pilot, and he develops the Unmanned Aircraft Systems program for Bowman Consulting. He also led the implementation and use of terrestrial and mobile LiDAR applications on projects in the state of Florida and the Southeast for Bowman. Seth is an adjunct leader or lecturer for Penn State's Surveying and Engineering program, where he teaches a variety of coursework as a reality capture consultant for Leica Geosystems. Seth draws on his rich technology background to guide surveying, mapping, and engineering professionals in achieving high productivity and a fast ROI on your technology journey. Also on the line with us today is reality capture expert Adam Westfall, who will assist with answering questions. Our session today is live, and both Seth and Adam will be answering your questions as we go through the material. If you do have questions, please enter those in the questions box, and we will get to those as we can. And of course, if there are extra questions at the end that we're unable to get to due to time constraints, we'll be sure to have someone reach out to you after the webinar by email. Before we get started today, we do have a few quick polls just to get a good idea of who is in the audience with us today. Our first poll is, how would you describe your experience with laser scanning? Go ahead and take a second to answer that. I know typically a lot of people are just consider themselves to still be learning. We're always learning, right? But some of you in the audience have been in this industry for quite some time, and I'm sure you could quite confidently consider yourselves point cloud pros. So go ahead and don't be shy if that's where you fit in. I'm going to go ahead and close this poll out and share those results. It does look like the majority of our audience is right there in the middle. Our next poll question is about pain points. So let's just see where people are here. And that is, what aspect of deliverable creation do you find the most tedious? Because there are a lot of things that you have to do in the creation of those deliverables, a lot of areas that we tend to get bogged down in, and we're just trying to get a handle on where those pain points are for those of you in the audience today. Looks like editing surface is a pretty big one here, as well as DTM and DSM modeling. I'm going to go ahead and close this poll out and share those results so that everyone in the audience can see where you fall in that spectrum. And then we just have one more quick poll here. This is a really easy yes or no question, and that is just whether you are already using Cyclone 3DR, because that is the software that Seth will be showing today. He'll show you how to overcome a lot of those issues that you are facing right now in creating those deliverables. So it looks like we've got an even split here in our audience. So that's great to see. I'm sure those of you who are not yet using Cyclone 3DR will find this to be interesting, and those who are already using it will learn something new from Seth today. So I will go ahead and share that out just so that you can see it. And with that, I am going to turn this presentation over to Seth. So whenever you are ready, Seth, you can go ahead and take it and share your screen.
Great, thank you. Thank you, Christine, for the introduction and the poll questions. Let me get my screen share going here. So as Christine mentioned, I'm here talking about Cyclone 3DR. We have a lot of users that use it, a lot of people that are working in the Leica reality capture ecosystem. It's a common software for them with doing their topos and producing normal survey deliverables. And then I've realized just from talking with customers, supporting customers, talking with other people that even aren't using Leica software, that most people tend to be, okay, I'm going to use the point cloud software to get what looks like normal survey data, and then I'm going to put it into CAD and just work with it from there. I'm going to do my surfaces in there. I'm going to maybe do some of the line work cleanup, generate my contours, things like that in there. And it makes sense because it's it's familiar. Most CAD techs are comfortable doing that if they're just bringing in a CSV and running field to finish or some DXF files for line work. It's easy to kind of keep moving with that, but there's some common issues that I see people running into with it where you're kind of reinventing the wheel, repeating some of those steps with cleaning up lines, running field to finish when you already drew your lines in something like 3DR, and then you find out, okay, well, this area doesn't quite have enough data, or maybe we brought in too much data and AutoCAD doesn't like the surface. So you end up having to go back and forth between these two softwares, and nobody likes doing that. It's always going to be easier the more you can get done working with just that single software. So then the way I'm proposing it today to all of you is using 3DR. We're gonna, do your data extraction like you're gonna get your break lines. If you want to do points on a grid, you can. You don't have to. The DTM tool that I'm going to talk about is kind of the nice thing to help with that. And then clean up your surface in there, get happy with it, simplify it down. We have a great tool for that. Export that out as a land XML, bring it in, and you have your surface ready to go. You can have your line work in that land XML as well. So I'm going to go through kind of a few slides that break down the tools that get used, and then we're going to pick it up in 3DR after, okay, we created a DTM surface, we have the break lines. Let's finish wrapping that up and getting it so it can get into AutoCAD. So again, everything we're going to talk about, DSM, DTM tools, incorporating break lines, editing the surfaces. We can create some contours quick. There's a nice, easy tool for that. How to get that surface from being just, way too many triangles that AutoCAD can't handle, but it may be really accurate, to how can we strip that down. AutoCAD has some tools for that, but they're not always the best. Sometimes you lose some detail, and it's really hard to visualize that in AutoCAD, which is where I like in 3DR. It's really easy to look at the surfaces and the meshes, as we call it for 3DR, and then getting that data into AutoCAD. So we have some tools. We're going to be mostly looking at the surface modeling ribbon in 3DR. So the main tools there to kind of get started at this point is the DTM and the DSM. So the pictures up top show a point cloud, then in the middle is the DSM, and on the right is actually a DTM filter. No cleanup, just the filter was just run on whatever settings 3DR recommended to me, and you could see kind of the data we have. It's dense. There's a lot of triangles there. Great mesh, a lot of details, but it's probably too much for what AutoCAD wants to handle. AutoCAD kind of wants to keep the meshes more basic. So that DSM tool, really easy to run. You just select your point cloud, and then you're just going to say, hey, what grid sizes do you want? So it's going to look at it's going to pretty much square off into little sections and then produce the DSM from there. I'm not going to show the tool. I have one I could pull up at the end that will show you that was used for those pictures. It does take a little while to run on a bigger data set. So still wanted to go over it because it has some cool uses. I actually will use the DSM to help me with pulling out my vegetation lines, maybe outlines for some buildings or some roof lines, things like that. You could do that in there pretty quick, partly automated. Main tool though, because we're talking about surveying, we're talking about surfaces, is that DTM tool. You open it up, this is what it's going to bring up. what it's going to want to run. So you could specify slope terrain, direction, extraction grid size, and then there's some other settings for it, as well as what you want to output. So first one, that the slope terrain, that's going to kind of vary. You're going to kind of base that off of what's going on with the data set that you run. Even if you have that turned up high, usually if you have your other settings set well, it's usually going to avoid, like, if there's some noise or vegetation. We have a setting that'll kind of adjust for that. So I tend to keep it turned up a little higher, just to hopefully catch my tops of banks and bottom of banks right out of the gate. The one below that with the direction. So for the more experienced users, there's a pretty cool trick you could use here. You could actually say, hey, instead of looking at a ground surface that's going to be horizontal going up, you could actually switch it, and you could run this on a wall. So like if you need to do a wall monitoring, but there's maybe some piping or wiring or vegetation on it, it's a really cool way to clean that out. I was talking to Adam, who's answering questions here for me. I was talking to him before this about that. Thought it was pretty cool to add. And then another nice thing to point out is the extraction grid size. I almost never change that. That actually is something that 3DR, looking at the metadata of your point cloud that you have, and some of the specifications of it, it's going to suggest a level of detail to run. I usually just leave that go, because if I need more detail in areas, that's probably where my break lines that I extract are coming from. And then when I mentioned filtering out the noisy points, so even if I have my max slope of the terrain set too high, it usually won't include any outliers. That's where I'm going to pick there on the right. So I usually will go with that check noisy points. And then there's a fast one. Maybe if it's just a really basic area, smooth, maybe you're just running it over a roadway, that would be the one to use. And then the local steep slopes is if there's maybe a lot of ditches or swales kind of moving along, or like a variety of terrain in your project. For the meshing strategy, I tend to go with the measured points is what I usually recommend. And that's because it's going to place the vertices on points from the point cloud. There's no interpolation happening or anything. It's not going to be a perfect regular grid. If you like your points on a grid though, you don't have to run points on a grid anymore. You could just set it to that regular, and then it's going to actually it's going to place a point to match whatever your extraction grid size is. So if I wanted to do it with points on a 10-foot grid, I could change my extraction grid size, select regular there, and I'm going to have a nice square grid going across the project. So keep going. Incorporating break lines, modifying the surface, and then editing the surface. So this is where I'm going to jump into 3DR, just because that DTM filter, it does not typically capture everything. We're going to need to add some extra data into it. So what I'm looking at, if I'm adding in any break lines, whether it's maybe a DXF file from stuff the field crew shot in or some points, I'm going to use one of these two tools under the surface modeling tab. I'm going to use that constrained mesh, or I'm going to use sharp edges. Sharp edges is usually what I'll use for things like curb. Constraint mesh is more for I have a great example of that, where it's an elevated platform that some HVAC equipment's on. There's a lot of data there where I just need to I'm just going to pretty much use top of the pad and then a bottom of the pad. I'm going to just create a whole new surface there and replace what the DTM gave me. And then for surface editing, we're going to still be in that surface modeling tab. We're going to be using some of the different tools there under the manual improvement and automatic improvement. I'm not going over every scenario of what you may have to do with some cleanup and trimming and everything, but I'm going to go through some typical things you may see, and we'll kind of work from there. I'd be here all day long if I was trying to go through every possible use of these tools. That you could get really in depth with this stuff very quickly. So let me jump over to my 3DR here. So I have a fairly basic, straightforward data set around a building. There's a little bit of a roadway. There is some elevation changes here. I mentioned that concrete pad with a wall on it that we have as well. That right there, that's where that is. So took the RTC 360, did pretty much scans all the way around this building on low resolution. I think it was about 30 scans, maybe 45 minutes it took. Nice and quick. And then from there, extracted out a bunch of data. So use the virtual surveyor tool that's in here under extract, and I started doing all of my line work here with it. So we have curb extracted out, we have sidewalks, we have a line going down along the around the building that we can use. This parking lot here for it, and then I'll turn those off just to keep that point cloud on. And what I did was I ran the DTM tool. So here's the settings that I ran for it. I'm not going to run it right now, just with the screen sharing and everything, and sharing my webcam. It tends to just take a couple of minutes longer than it has to, and I don't want to have to wait on anything like that. I don't want to have to not be able to cover everything, so we're going to leave that go. And what I ended up getting out of it was this mesh right here, and then I'll show you the ground that it gave me. So the DTM tool is kind of two tools built into one. If it's the split ground points tool, as well as creating a 3D mesh. So it's really just running two steps for us. And that's what you can see here. This is that ground mesh that I had. And right off the bat, because this is a lot of rolling hills, it did a really good job picking that up for me. Things like curb, those sharp edges, it doesn't always pick up, of course. So we need to, those are where those break lines that I extracted come into play. Those are always still needed, right? People still want to see where the sidewalk and the curb is. If I select my surface, it turns purple. I could right click and I'm going to change I could change the representation of it. I could change the color of it. I could do some different things. So what I like to do is I like to turn on, it's called smooth and wire. The wire is going to show me my triangles. So you can see this is a pretty regular grid of points here, that every 2 foot or so. You can start to see there's some detail to the road, but it's not perfect. We have a bunch of triangles in this building here. So this is really where you're gonna start using the tools and jumping in here. I'm gonna turn on my virtual surveyor line work that I did for the building outline. If I select the surface, the first tool to talk about is the clean and separate. So clean and separate, I could just draw a line and it's going to select the points in that line and I can delete them out. So I can say, hey, delete those points. I could hit undo, bring the points back. I could still delete. I could delete some other points. I could say, never mind, reset. So I could use that. I could go in here and I could clean up around all these triangles and take my time deleting them out. It's a little bit cumbersome. It's a little labor intensive, right? Another way that we can go about editing those, so down bottom, it gives us this toolbar, and the one option is by size. So I could say, hey, any triangles over a certain number, and I could use this slider bar for how many feet, and it starts to trim out some of these longer triangles for me. And from there, I could go, hey, delete, and they're gone. Pretty nice little trick there to get rid of longer or maybe the really small triangles you don't want to keep. I'm going to just leave them go for now, and I'm going to close out of that tool. The other way, what I'm going to do to actually clean out inside the building area the best, since I was lucky, I was able to go around and do a line right around this building. I'm going to select the line, hold my control, and select my mesh as well. And I'm going to go up top to, there's a tool up here, cut mesh. And I'll hit my preview button first so you can see. So it turned into, I have a red mesh and a blue mesh. They're totally different. So that is pretty much like a bounding box. Every line inside of that mesh, it's gonna remove for me. So I'm gonna hit OK. I'm actually just gonna select that middle one now, press delete, and it's gone. I cleaned out inside that building, just like that. Nice, quick, and easy here. So let me change. I'm gonna change my mesh color back. It likes to switch colors on you when you run some of these tools. When you're like splitting apart the meshes, certain colors just for me, they don't always show up the best. So I like working with the yellow with the blue triangles here. Come up to the roadway, turn my point cloud back on so everybody can see it. So I'll turn off the mesh for a second. So some curb here that we extracted. There is some drainage. There's drainage there, drainage right here as well. So what I'm going to do is I'm going to use that line work. I'll actually just go and select all my line work right now and my surface, and I'm going to come up to the sharp edges tool. When you run the sharp edges tool, the only option you have is a cleaning distance. So if there's any triangles within this amount of space of the lines that you're adding, it's actually going to remove them. So that's when it becomes helpful because of things like the sidewalk here. So there's a lot of extra points on these sidewalks, but because I drew each side of the sidewalks, these are probably a lot of points I don't actually need. So I'm happy the civil engineers that are going to use this for a design are happy with, we're just, having the two edges of the sidewalk and calling that good enough. So they can get a cross slope with it nice and easy. I'm going to run preview, and you can see that it does some cleaning up here. My curb already now shows much better. I actually have my curb in there. That worked really well. And then these triangles again along either side have cleaned up. Sometimes maybe the sidewalks I want to go with like a 10-foot cleaning distance instead of the 5-foot or 3-foot. So I may add things in at different intervals to this. I'm just going to hit OK there. So now we have a nice surface. We have our lines in. We have our curbs in. We have the nice curb cut there with it. Everything's getting utilized. I'm going to come back over here. So I talked about this concrete pad. The triangles are a mess in here. So I could go about easily cleaning this up with using the clean and separate, removing out these triangles, deleting them. And then we have another tool here for filling holes. So I select that hole and say, hey, try to fill it in. It's still not flat. It's kind of just doing an interpolation there still. So it works well for maybe small gaps in your data, but it does not work well on something bigger like this. I go back. Another option could be I could run this tool next to it, so it's smooth mesh. So you specify a brush size, so I can make it, nice and big. I can make it nice and small. And then an intensity. So how much do you want it to smooth? And as I click around, it'll kind of smooth this down for me. So I'm not seeing a lot of changes in color now, so I probably got it pretty close to a smooth surface there now. And that's probably good. But what seems to keep happening is right around the edges. So it didn't like this concrete right here. It didn't like this wall pretty much on the corner. It's missing some points there. So what I'm gonna do is something real similar to what we did with the building. I'm going to select these two lines for this concrete pad. and I'm going to do that cut mesh. And make sure you have the project poly lines on, so then it's going to hold those lines all the way and put them out for you. And now I have a couple different meshes. I have a top mesh here that I could delete out, and then there's this mesh on the sides. Really, the only mesh I need to keep is the red one, so I'm gonna just remove all these. So now I cleaned up all those points, and what I'm going to do, we talked about the sharp edges tool. That tends to be what I use for more basic things like curb. When I'm doing things like walls or platforms like this, what I tend to use instead is the constrained mesh. So constraint mesh is for really what you're going to want to use if you're bringing in maybe data that was the shot in the field, maybe they picked up some obscured areas. You're going to want to use the constrained mesh to create those, incorporate those into the surface. So constraint mesh is pretty much saying, treat this like the LiDAR point cloud. We want to build a surface from these. So I have these two lines selected, the blue and the yellow, and I'm going to hit preview, and it builds me this nice, much more simple, easy to look at and understand box of a platform that was going on. So I'm going to say okay, and I'm going to hold that, and it's two different meshes now. It's as simple as hold my control key, select both of them, and then I'm going to do group. And then do you want to orient all the parts the same way? Yep, I do. And now it's all back together into a single mesh. So I have that. Right here's a kind of a funky triangle that happened. We could probably try to get that cleaned up even too. So what I'll try there first is smooth. That didn't work. So what we can do is do that, and I'm going to delete them, and then I'm going to do that fill hole command now. I'm going to try to fill this hole, but it has that point over there. So just actually looks like what's going on is if I switch to my top-down view, this one, it's pretty much an intersecting break line. So even though I drew it, I didn't draw it right. So got one more triangle here I need to remove out. Delete. Okay. We'll try the fill hole one more time. Cancel. So I'm going to add, I have this edge of the sidewalk here. I'm going to add that in as a constraint. So then nothing's going to cross it. And then now we should be able to fill this hole in. And that cleared that up. So that's kind of the difference with that constraint versus the sharp edges. Sometimes with your surface, if you're just relying on sharp edges, if your lines are intersecting or very, very close to each other, it may want to hold one point over the other, and you get that kind of funky triangle there. So what I did was I took that lower line that it was ignoring, I added it in as a constraint, and then I was able to use the fill hole command to fill in for those triangles I deleted out that were causing a problem. So since we talked about smoothing the mesh, filling some holes, using the cut to remove stuff, another thing, so I mean this mesh extends way beyond where I did my data extraction. So what I could always do, I'm going to come up to the file and I'm going to import. If I go to my import here, I have a boundary I'm going to import. So think of it like it's a CAD file. I had the boundary in CAD. I'm going to just import. I'm going to say, hey, it's US survey feet. And now I have this line that came in that's green. So I could use that same green line. I'm going to say, hey, cut my mesh. And then hit OK. So now I can delete out this. And I have these two meshes in here still. I'm going to just group that back together, the platform. And now I have my mesh trimmed down. So if I go to a top-down view, so it's pretty much keeping my triangles that fall inside of it. So there is a little bit of a gap here with how it clipped it. So I typically will extend it out a little further than what maybe my actual limits are. Because of that, because you'll end up with some of these gaps, because it's cutting off your triangles. It's not going to let any bigger triangles on one, extend past it too far. So now I have here a nice cleaned up surface, and really it's some of the modifying things like we did over here with the sidewalk and adding in this platform. That's really the hardest part of it. It's pretty simplified there. And other than that, with cleaning it up and removing what you need to, this gap is just purely because the line was drawn at a single elevation and the triangles are below it. So I'm gonna turn that off now. Jump back to my PowerPoint here. So we covered the surface editing and adding in break lines, some of the different tools in there and some different things that you may come across. Next is the creating contours, and this is probably the easiest thing to do. So we're going to, under the extract tab, there is the contour lines. Jumping back into 3DR. I'm going to select my surface and I'm going to go to the extract tab and then contour lines. So when you're in here, you have a few options. So the step and then the major contour frequency are what you're going to want to control. So whether it's, maybe your contours are every 2 foot and your major contours are 10 foot. In my case, I'm doing 1 foot and 5 foot. And then I could change the color of them. So if I want them to be a specific color, I could always change it. I can go to my preview here, and now I have contours. Turn off my mesh. There's the contours for me. They are 3D lines. I don't recommend it, but there are people that try to create 3D surfaces in CAD using contour lines. You end up with a plateau though, so I don't usually recommend that. One other quick tool to show that I didn't include in the outline, but I'll do like showing it here, is under the extract tab we have a different command for break lines. So even if you're watching all this and you go, I still don't want to build my I still don't want to build my surfaces in 3DR, or maybe I want to build some in there, but it still makes sense to build others in AutoCAD. Things like your common rolling break lines, like rolling hills, maybe your top of banks and bottom of banks, they're kind of subjective to extract out with what you need and where they're at. So we have a tool that's multiple break lines. The multiple break lines tool, I know we've covered it in other webinars. It's going to look at this mesh and go, how can we recreate this using just 3D brake lines. So I'm going to leave these settings the way they are. I'm not going to mess with them or anything yet. Again, these are kind of recommended settings that 3DR gave me for this. And I'm going to hit preview. And it's not perfect, right? But again, these are just mathematically placed brake lines where if I wanted to recreate this surface and get something similar in CAD, these are the brake lines I'd need. You could definitely recycle some of these. I mean, looking here along the road, I have something along the center of the road. I actually have some close to the curb, so it's not going to be exact, but it's going to be kind of close. I can adjust my settings though. I can say, hey, maybe I don't want all the lines. I just want some of the major ones. See what we can come up with here. Do my preview again. Take it down. Maybe I want more of these lines. So I could say, okay, change my length. Changing the length is going to change how many vertices it places. So and then I could actually select these lines. I could go to the clean edit and I could smooth them out. So I'm just gonna say, hey, hard, smoothing intensity. Now these look a little bit more like what I would have for, you know, this red one as a top of bank, and over here is a top of bank. These blue ones, I could probably recycle some of them as my bottom of banks, center line of the road. So it's a good way to kind of pull some of that out and make sure you're not missing something. So I mean, if I just drew in the center line of this road, maybe I miss where it jog, the actual crown jogs over a little bit because of an intersection or something. You see a little bit of that here where there's the ADA ramp. It kind of juts over just that little bit. I have those here. Extra little thing I wanted to show. If I go back to the extract and the brake lines, I could actually do extract a single brake line. So this is sometimes a little easier for getting like my tops of banks. It will, where I click, it's going to kind of follow along the tin surface for me and try to pull out a pretty much a single brake line like it says, or follow a contour. So. And then I could use that for, I'll use it for going around like vegetation. I'll use that with the DSM tool. So the DSM tool is going to show the higher points, like the tops of my trees and the edges of my wood lines. So I'll use this tool to kind of work around those as well. But for contours, straightforward, they're right here. They can always be exported, sent to CAD, and they'll go right into CAD. So I'll open up a civil 3D drawing here for it. So while that's opening in the background, it may take a minute. So creating contours, as I said, the main the main ones you want to worry about is your step and the contour frequency. If you want a contour at a very specific number, or like a specific elevation, you could use pass through and it'll do that for you, or you could specify an actual value. If you're doing stuff for like flood mapping, maybe base flood elevations, that could be helpful for you. Scan it, run that, and you can see where that contour line is for what's above and below the flood contours, the flood base elevation. Jump back. So the simplifying, work through creating contours, moving on. So I mean, right now we still have this surface that's a lot of triangles. It's probably very dense. AutoCAD doesn't like those really dense surfaces. You could bring it into AutoCAD, and AutoCAD has some tools for editing it out and simplifying down and removing vertices, but they're not. Sometimes they're a little too strict, and they remove a little bit too much, and you lose some of your detail. So this is kind of a nice benefit, and this is usually where I win some people over with running this tool, running their surfaces fully through 3DR before putting them in AutoCAD. So we're still under that surface modeling tab, and then there's a handy little tool called reduce. So when you run the reduce, it comes up, here's your menu that it brings up for you. These are not default settings. These are kind of some settings I recommend for people. So I don't like to do keep the aspect. Keep the aspect means, okay, we're just going to remove a percentage of your triangles. Well, how do I know you're not removing the triangles that I need? Because I need the detail in a certain area. So I tend to go with that control deviation. And then with the control deviation, I tend to with control deviation, I tend to think of it as, okay, what's my project? You know, what's my allowable error on this project? Maybe for my topo, it's 1/10. Well, okay, we're taking into account things like the scanner accuracy, maybe how my registration was for it, and how I checked into my control with my scan registration, and then, okay, we did this DTM tool. I don't want to lose much more, because every step of the way I'm going to lose some. I may be losing some of my accuracy. So I tend to keep my deviation somewhere around 400ths or 600ths of a foot. And you'll see that you'll still end up reducing a lot of the triangles. A lot of the ones we don't need are in there. So some other options. So I mean, there's one here, optimize vertices position. It'll shift around the vertices a little bit to help again with keeping that deviation and remove as much triangles as possible. But a lot of the sharp edges that we just removed could possibly be removed as well. We may lose some of them. We have to go back and repeat some steps. That's where the setting below preserve sharp edges comes into play. So I put mine, so I'm thinking curb. In a perfect world, a curb face is probably pretty close to vertical. So I'm going to keep that around 90 degrees. Maybe I keep it at 85 degrees, 90 degrees, 95 degrees, whatever it is. And then I can specify a whole other deviation for it. So I'll usually put that at 2 or 300ths. It'll be half of what I do for my deviation parameter. And what you end up with running it through, I reduced in this one that I used for this example, it reduced almost 85% of the triangles, 84% of the triangles are out. You'll see my maximum deviation is just under 600ths. Well, of course it is. My deviation up here is set for that value, so I know it worked. But then it's also giving me an average deviation. So this is what I'm going to typically find across that really detailed DTM that we just made and versus this lighter weight one we're putting into CAD. And then I have a total number of triangles put with it too, which is great. So 84% saved. What does that mean? In this case, I'm reducing my file size for an XML by 85%. So that's keeping it as lightweight as possible. That's going to help you a lot with your bringing it into CAD. You start to get some of these bigger or more detailed surfaces. CAD does not like working with them. It does not like visualizing them, generating the contours, doing any editing. So this is just a great way to reduce it down and get it as small as possible while preserving as much detail as possible. So I could jump back here to this surface. I'll turn off these contours. So I'm going to run that tool right now. I'll run it on this surface we just created. Let's see, we'll go with that 400th, and then I'm gonna change this down. I'm gonna go with 89 degrees, because if I have that at 895, I could have some triangles that are inverted. This software doesn't care about triangles going back on itself. AutoCAD it's thinking of it more as a surface. It shouldn't have vertical faces necessarily unless it's a wall. So I'm going to set it up like this. I'm going to hit my preview button and see what it did. So right off the bat, it reduced 70% of my triangles. We're down to 6,800 triangle faces. Average deviation is 12,000th, and my maximum deviation is that 400th. I'll bump it back up to, I'll do the 600th now. So now I'm up to 80%. I went from 70% to 80%, and my number of triangles dropped even further to 4,500. So I'll leave that. And then the key thing to go and check when you do this is you're going to want to look at your curbs. You want to make sure. In this case, it actually threw out a lot of my back of curb just because it's probably not a big difference from my from my face of curb with elevation. So it's like, okay, those are just extra triangles we don't need. We're trying to get this as lightweight as possible. You can still see the ADA ramp there with it, the curb cut out. Same thing over here. If I wanted to include those, I really wanted my back of curb, then I can go back in. Maybe I should have added these in as, I'll do it with my building as well. Maybe I should have added these in as a constraint mesh. I could always just add them back in as a sharp edge. Say, hey, use that clean distance here. Maybe just 2 feet now. I'll run a preview. Then now, it's actually skipped over my edge of pavement. Oops. So I'll go back. What I should have done, I should have selected that whole curb here. And you can see it's holding all the face of curb points because there's that big vertical drop. But I could do it this way, sharp edges, and if there's anything that's been removed, I could just get it added back in real fast here again. And now it's holding my vertices on my back of curb for me. So we have that. Over here, it's still holding this nice platform, concrete pad that we did. No worries there. Everything else, it's ready to go really for an AutoCAD. So to get it into AutoCAD, when we bring stuff in, we like to do the send to. AutoCAD drops it right into place. Doing that with a mesh gets a little tricky. If you do send to, you end up, it's going to bring it in as the triangle faces. It's not a surface. You can make it a surface really easy, but if you have to add other data in or make any corrections, good luck. It gets really messy. So that's why I'm showing you exporting it out as a land XML and bringing it into AutoCAD. So go back here to my 3DR. As I said, I have an AutoCAD drawing open here. I'll open up real quick. So first we'll bring in I'll bring in the contour lines just so we know where everything is. So right there they are, perfect. If I want to, I could actually just bring in. We'll just bring these in too for the fun of it. Right click, send to, AutoCAD. They're all in here as well. I have all my line work now. These are just point labels. These are just note labels. They're not the actual points or anything. So a little bit of a cleanup there with it, which is a bit of a pain. But now if I do my mesh, send to, drawing, it brings it in as a mesh. I don't want it as a mesh in here. I'm working in Civil 3D. I want it as a surface. So you could create a surface and add it in, but having it as a mesh, and even if you explode it, you end up with 3D faces. you really can't edit those. You won't be able to really clean up your surface if there is some last minute revisions or some things you need to revise in here. So instead, what you want to do is select your mesh in 3DR. We could do the file export selected visible objects. Then we want to export it as, I'm just going to call it lunch and learn. And I'm going to switch it to the XML. And then I'll jump back over to AutoCAD and I'll import that XML. And you'll see right here, it says there's a surface. I can bring it right in. So I'm gonna select all these triangles and remove them. And we have our surface in here. So it's showing 2-foot contours. That's why it's not showing every contour, but you can see this common contour. It shows up very similar. AutoCAD is of course running the tin faces a little differently. You're able to flip your tin faces if you need to in here to finish cleaning it up. You can smooth your contours in here that it has. All that's possible. So those, and there's our surface. So that is really the end of everything I wanted to cover in this. We have right about that 10 minutes left for questions, which is great. I'm not sure if we had any that haven't really been answered.
Yeah, so Adam has been doing a fantastic job of keeping up with the questions behind the scenes, but I did want to ask, there was one question that came in early that really just indicated we should back up a little bit and talk about Cyclone 3DR and where it fits into the overall workflow. I think for the half of our audience here today that's already using Cyclone 3DR, these were some fabulous tips that they can take back and start implementing right away. But for those who aren't familiar with Cyclone 3DR and maybe aren't even familiar with Leica's overall reality capture workflow, where does Cyclone 3DR fit in?
So in the past, most people who are long-term users are familiar with just Cyclone, and Cyclone was kind of a do-it-all tool. You could do your registration in there. You could have other licenses to do all your data extraction in there as well. Now, the next evolution of our software, we have our registration software, which is Register 360 Plus, and then it's what do you want to use from there to work with your point cloud data. So that's where 3DR is. It's a data analysis, data extraction tool. So you can run. We have tools in there for classifying point clouds, cleaning them up, maybe doing floor levelness, floor flatness, wall monitoring, stockpile volumes, or just normal break line stuff like you would need for a normal survey, which is kind of what I was working with.
Okay, great. And is that something that, does someone have to be using Leica Geosystems reality capture tools in order to use Cyclone, Reg 360, and Cyclone 3DR, or can they be using other sensors?
So Register 360 Plus is for registering registering scans from our hardware, but Cyclone 3DR is meant for it's scanner agnostic, as we call it. It's meant for just any type of point cloud. I've worked with state LiDAR data in there. I've worked with drone data. I've worked with data from other scanners in here all the time. If my customers are doing that, I'm gonna, I've jumped in and showed them how to work with some of that data. So it doesn't matter what kind of a point cloud it is, you can work with it in this software.
Okay, that's good to know. And there are some firms that are using multiple sensors from multiple manufacturers. And so it's helpful to have something that can work with all of those different tools. Now, for the data that you were showing us today, are you able to share what you used to collect that data? It doesn't even matter what you used. I mean, obviously it looked like a really nice data set starting out. What did you use to collect that?
So this was done with the RTC 360. Everybody loves the RTC, great point clouds out of it. But it doesn't, you could work with other stuff. I had some BLK to go data sets I didn't, that I was running through before, but it was just, instead of jumping between data sets, this one kind of had a little bit of everything. So I just kind of used that for the webinar. But there'll probably be some follow-up videos I post online that'll use some other scanners. So.
Okay, great. Yeah, we'll look for those. And now this was the last, I think you said like 10 to 20% of a workflow. You were really trying to show people how to speed up, accelerate getting to that deliverable. What impact does the front end of that workflow have on once you get to this side of it? You know, making sure that you have a clean data set, making sure that you're following the right procedures. What impact does all of that have on how quickly you're able to get into that final deliverable once you get to this stage?
Well, of course, the more you're able to capture and draw out, like as those break lines, like I've mentioned, the poly lines, that's going to help you with your surface because you're capturing all the key elements in the surface. So then let the DTM tool get all the other stuff. So you don't need to try doing points on a grid in certain areas or like drawing extra break lines. You just need to worry about the important ones. Where's the sidewalk? Where's the walls, the buildings, things like that, center of the road, curbs, drainage, things, things of those nature. So if you take the time to get all that ahead of time, it makes this really it's kind of like a domino effect. The whole process, even in the field, if you doing a couple extra scans to make sure you pick up everything well, makes registration quicker, it makes your data extraction quicker, and it makes you get that end deliverable even quicker. So as long as they don't cut a corner to save an hour in the field, you're going to save a lot more hours as you move through this whole process. And that's what I kind of wanted to show. So it's pretty much, it's going to make a big effect for that. And we had one webinar previously done by Jason Dixon, and he covered really well just how to clean up a point cloud really quick and start drawing your line work really quick. So pretty much the steps I didn't cover. So if you go on the Pure Surveying website, you can probably search back and find that webinar. And this is kind of, to me, it's almost like a follow-up to that and some of the other ones we've talked about to help you kind of have a full workflow. It's a lot to cover in just one webinar. So.
For sure, but you did a fabulous job. We'll make sure to include those links that you mentioned in that follow-up email to everyone who's on the webinar today. So Seth, that is fantastic. Thank you so much for that. Adam, I know you've been doing a great job of keeping up with those questions. Is there anything that came in during the webinar that you think bears repeating to our live audience here?
Just the questions I answered to all. There are some requests for additional things, and I just want to reiterate what Seth said. You can go kind of shop, pick and choose on the Pure Surveying webinar series, and there's a ton of free training available in there. So if some of the questions that weren't answered, I guarantee as far as civil topo workflows and survey workflows, those will be answered in a previous webinar. And I will say some of the answers might be a little contradictory as software versions get updated, so always check back and look. But no, it's Seth did a great job. There was only about a quarter of the questions of normal. So
yeah, that's always everything before people could ask it.
Yeah.
All right.
So I did see one question, Adam, that you answered. I don't know if you answered to all. Was the point cloud classified, segmented before running the DTM tool? It was not. I skipped that whole step. I just started working. So I'll classify my point clouds when there's a lot of if there's a lot of noise that I have to clean up, like from cars on the roads, or maybe if there's a lot of 2D things I need to pick out, like signs and light poles and trees and things like that. But for this webinar, since we're talking about the surface, no, I didn't even do that. The DTM tool in here is great, runs really fast, so I didn't have to rely on that.
Okay, good to know. Well, that does bring us to the end of our session here today. Seth and Adam, thank you so much for your knowledge and expertise, for sharing that with our audience. For those of you who are on the line, please do take a moment to answer the exit survey as you leave the webinar today. That will help us to develop some additional content for you in the future. We hope this has been a valuable amount of time for you today. Thank you so much.
Thank you, everyone.